function of inverse. Whew. Cotangent. Let me give you 2 minutes to kind of talk to one another of how to start. Can you graph a pi to the right and a negative pi to the left? Okay.
I kind of remember let's put 1 over all the y value. Y equals secant of x. If the ones are all y equals secant of x. Yeah. So you just tangent goes up this way, and that means this thing goes up. No, we're not. We're graphing cotangent. Yes. So if tangent goes up this way, cotangent is going up this way. Cotangent up this, tangent is like yeah. Yeah, like that, yeah, like that.
What did you guys do?
What?
Okay, we will start with points, okay? I will have 5 points. There you go. 1, 2, 3, 4, and 5. We're going to start with input 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay? All right, let's start. Cotangent is what divided by what? 1 divided by tangent, or? No, cotangent is not the inverse of tangent. Cosine divided by sine. Beautiful. Here we go. Are we ready? Jack! Cotangent at 0. Undefined. Is he okay? Yeah? He's right. That is true. Okay. Danielle, L. Cotangent pi over 4. Yes, it is. It is a Friday. Megan, cotangent pi over 2. Oh, it's asleep. Perfect. Nice job. Are we like unsure about these outputs?
Wait, doesn't the 0 with the cross there be? Oh, that's undefined.
Undefined, yes. Yes, sir. Now is cotangent of 3 pi over 4. -1. Beautiful. Nicely done. And last one, cotangent pi. Yes, sir. All right. Okay, here we go. I need asymptotes. Okay. Pi over 4. Are you guys okay back there? Okay. 0, negative. Okay. Okie dokie. All right, Justin. Is this a 1-to-1? No. Okay. Because Justin says no, we have to cut it. So it can be a 1-to-1. Okay. You have been invited to a meeting. Are you ready? Okay. Nathaniel, you are in a group with mathematicians. You have to cut this off. Where do you want to cut it off so it can be 1 to 1?
0 to pi.
Yes. Accept. 0 to pi. Non-inclusive, right, class? Yeah. Then we are now going to define it. Here we go. X equals cotangent of y. Am I going too fast? Okay. Okay, solve. Y equals f inverse symbol of x equals cotangent inverse of x. Just like in algebra 2 trick, I will also accept cotangent of x. Okay. Then we are going to definitely define the domain of cotangent inverse.
Do we do this every time?
We do it every
We
time.
don't test, like, we'll just do
Okay? No, I just need you to know so you can find the values. Right? Can you find the values if you don't know the domain and range? No, you don't know where it goes. Okay? It's like us driving around without our navigation system. All right, Cade, what is the domain of cotangent inverse?
0, pi, non-inclusive.
0, pi, non-inclusive of the ends. Is he right for the domain of cotangent inverse? Josh says no, but it's more like a question mark no. Yes or no? No. The domain of the inverse is like the range of the regular, right? What's the range of the regular? That's right. Negative infinity to the infinity. Nice job. Then now, Cade, what is the range of our cotangent inverse? Yes. Okay. I'm sorry, over pi. Oh my gosh. He said pi. I just wasn't listening. Or this. All right. Quadrants. Okay. Is it 1 and 4? Is it 1 and 4? No? Is it 1 and 4? So let's look. Is it 1 and 4? 0 to what? Because as you know, more often I would just say, hey, you know what 2 quadrants is cotangent inverse in? And you would say 1 and 2. That's right. Okay. Let's recap, okay? How many of the cotangents are in 1 and 2? Let's name them. 1 and 2, restriction. Restricted in 1 and 2, quads 1 and 2. Cotangent inverse for sure, right? What else? We just did one before that, which is secant inverse. What else? And then cosine inverse, those 3 of them. That means how many are in 1 and 4? Tangent inverse, sine inverse, cosecant inverse. So guess what? The 3 and 3. All right? Okay. Now, graphing out the cotangent inverse, I'm going to have to do it twice, 2 different ways. So you can see how we can get cotangent inverse differently. Okay. So the first one, something on my eye. The first one, when I do it normally, we are just going to go from 0 to pi. 0 to pi, 0 to pi, 0 to negative pi, and 0 to negative pi. Half pi is right in the center, but 1/3, 1 is 1/3 of its way. So I'll just write 1 right here, -1 right here, -1, and -1. Okay, so those are my -1 marks. So again, we're going to graph out the regular cotangent first and then just reflect it. So the regular cotangent have asymptotes at 0 and where else? Pi. Okay. Then I'm just make my dots. Here we go. 1/4 pi over 4 go up to 1, right class? At pi over 2 goes to 0. At 3 pi over 4 goes to -1. And then here's my regular cotangent with restricted domain. So y equals cotangent of x. Now I'm going to draw its inverse. Should we start with the asymptotes? Sure. Where? Pi and where? And 0, right? At the x-axis? Good. Similarly, I'm going to need you to plot in 3 points. What's your first point? Pi over 2, 0. So pi over 2 is right here. Would I say here? No, okay. That was pi over 2, 0 though. So how would you switch that? 0 comma pi over 2. So wouldn't that be right here? Yep. Now what? 2 more points. 2 more points. 1 comma pi over 4. Okay, so 1's right here, comma pi over 4 is right here. 1 more point. Negative 1 comma 3 pi over 4. Okay. And I'm going to turn my paper sideways because I can't really draw nicely if it's... I'm not a very good drawer, grapher. Okay. There you go. Now, if I were to draw this line, this beautiful line called y equals x, do they look like they may be symmetrical? Yeah. Okay. So which one's the inverse function, the blue or the orange?
Red.
The red. Okay. Orange, red, whatever your color is. Now I'm going to do another one using cotangent inverse to see the relationship, okay? So down the bottom, don't graph it yet. I will give you plenty of time to graph. I just want you to pay attention. We will graph out tangent inverse first. So this is pi, this is pi, this is negative pi, this is negative pi. Okay. Tangent inverse, can someone tell me, where do we start? Do we have asymptotes in tangent inverse? Yep. Where? Where were the 2 or 1 asymptote? Pi over 2. Horizontally or vertically? Horizontally. So here's pi, so pi over 2 is right here. Okay, just pay attention, and then I'll give you plenty of time. I'm graphing out tangent inverse, okay? Now, what are the dots for tangent inverse? 0, comma 0. Is that okay? Yeah? Okay. Would that be an okay dot? I'm just asking. Make sure we're on. Yes or no? Ben? Yes, okay. Another dot.
I'm gonna say
should I have another asymptote somewhere in there? Yeah? Where's the other asymptote? Probably if I... Huh? 0 pi, 0 up pi, like here? Up there? Not an asymptote. A dot, you mean? Yeah. Chase? Okay. So Chase said there's a dot, 0 pi. Is that another one? That doesn't look like a function with the 2 dots. Yep.
Your asymptote should be at y equals negative pi over 2.
Y equals negative pi over 2. Do you agree with Patrick? Yeah, yeah. If I put in 2 asymptote, you guys will probably have a better...
Patrick,
Bye, Patrick.
Ben.
1, so -1, negative pi over 4.
Yes, I will accept. Okay. Then 1 is positive pi over 4. All right, so here's your tangent inverse graph.
Wait,
I'm sorry. y equals, is that okay so far?
I think it's backwards.
Yeah? No? Maybe?
What's that?
I'm just asking.
What's it?
Does it look like what your notes should have?
Yeah.
Okay. Now look at the orange.
Red.
Look at the orange, red, whatever color you think it is. How can I use this tangent inverse and make it to look exactly like the red/orange color? First, what can I do?
Negative.
Make it negative. What do you mean? Make what negative? Reflection about the what? Yeah, can I take a reflection about the y-axis? So here we go. I'm going to sketch it out. What that means is whatever's on the right is now on the left, and whatever's on the left is now on the right. Okay, don't sketch.
Can you make the x or y one negative or just the y?
Okay, so we'll do one at a time. Okay, so if I make the reflection over the y, is now y equals tangent inverse of, beautiful. It's kind of now in the right direction, but is it the same spot? No, what else you to do? Bring it
Vertically.
up. How much up? Pi over 2, which one? Pi over 2. So that means this dot is not here, right, y'all? This dot is not here, and this dot is here. So check this out. Sorry, sideways. Okay, so do you think that should be like cotangent inverse? Yeah. So I brought it up by a pi over 2. So what do I do with that? Add outside pi over 2. Okay. Now tangent inverse or tangent, is it an odd function or an even function? Tangent? It's odd. So if you have an odd function and if it's a negative angle, what can you do? Put it on the outside. So it's like negative tangent of a positive x plus pi over 2. Now, this is the equation that you can get if you are asked to find cotangent inverse. Now, as you know, most book probably does not like that negative in the front. So if you see this, okay, they can also move the pi in the front, pi over 2 in the front. Can you see this? Minus tangent inverse of x. Okay, that's all the same. Okay, so this is one way of getting cotangent value. Okay, and we just proved why that is the way that is. And there's another way that I will demonstrate when we do some examples. Okay. Any questions on that at all? Do you guys see how that turns into? Yeah. All right, example, exact value. Calc or non-calc?
Non-calc.
Non-calc. That means it's all in the brain.
30 degrees.
Oh, it's 30 degrees. Is that answer correct for A, apple? That's fast. Cosecant inverse of 2, what's the exact answer?